Hello and welcome to another video on the complete intro to SQL and Postgres. The whole idea of this series of videos is to keep up the pace and update my knowledge with Postgres, especially the version 14, and move on with later on the other versions since the current one is 16. So as I look at in the as I look in the past about how to create SQL and what is SQL and what is Postgres, I have experience on that. This course is taught by Brian Holt, the front-end master, which is a software engineer that has previously worked at Reddit, Microsoft, Netflix, and now he is the product manager of Snowflake. All right, he's currently now move on from that position to now get on the startup air arena in Mexico. Okay, which is very interesting. The path he's taking. All right, so this course is, or in today's video, we're gonna look at the joins, which is a very sensitive topic uh, for a practical in a practical side, right? So what are the techniques and tactics, and also understanding is the main concept, especially when you are now not only query data, but also when you want to combine uh, or when you want to reach into two different tables and combine their data, okay, as a way to now explore that and get some. This is something powerful and useful for business as a way to get insight about what's going on in their field or in their business. Something that is very in demand by a lot of companies, and I see why. Now, with that little bit introduction, we went over to the SQL, Postgres, what this course is all about, what is this course for, what is this course for, which is for developers. This is not for DBA, database administrator, because here we're not going to see is how to maintain a Postgres instance, how to do replicate database, how to deploy Postgres. None of that. Here we're gonna focus is on the developer aspect, which is well, how to set up a Postgres instance and creating database. Also, how to think about data, uh, getting into tables, all right, and then how or the best way to write queries for your application, and then how you can identify and optimize slow query, something that is very highly in demand. And I will say, and I will argue that this is for the vast majority of company where they need someone that actually are capable of doing that. And then lastly, how you can now integrate that with a server, in our case, Node.js, which is something that I have experience. So as we move on, we look at the difference between SQL and the Postgres and how SQL here is the specification that come from the ISO, the International Standard Organization, when they have different topic, different strategic topic to or challenge across the world. All right. So whether it's on health, transportations, management, social environment, technologies, uh, engineering, industry, all of these sectors, and how. Okay, that's interesting because this is where we are going to look at this exactly. Interesting. Interesting. I don't know if you're able to see this right now. Yeah, you're able. Uh, but the point of this, but the point of this, all right, is that now you are able to follow this kind of metrics, this kind of standards, okay, as a way to familiarize yourself with the terminology, the practice that they are promoting, right? Uh, so that's something interesting. Again, all of this come from this internationalization or this international standard organization. All right. So, okay. Ah, that's right. If you want to look at more, okay, okay. If you want to take a look at deep here, all right. If you want to take a closer look of this, oh my God, well, you should buy this as it is. All right, interesting, interesting. But again, uh, yes, I also look at that these standards or that this SQL, what is SQL, what is Postgres, so SQL is this is standard. It's like the recipe cookbook. And Postgres, MariaDB, SQL Server, IBM uh, all of this database, all of these are database management systems. In other words, this is like your kitchen fully stocked with all the tools ready for cooking. So if you once you have these mental models, okay, which is very very interesting and important, it's like okay, now things are starting to make more practical, more tangible. Okay, anytime you're going to interact with each one of those kitchens or each one of those uh, management systems. In our case, it'll be Postgres. Another example is like since SQL is the language, you can think of the Postgres, SQL, MySQL, MariaDB, IBM and SQL Server like the environment in which SQL is being run. So in JavaScript, we have different environments, not only for the browser, but also for the node, Dino, Green Rhino, JavaScript for IoT. That's a very interesting. Didn't know about that until right now. And then we look at well, how we're going to set up our database or this introduction here as a way to look at the database and the tables, how we're going to set up the Postgres tables, how we're going to set up first is our uh, Postgres instance using Docker, and from there, how we can now get into the actual Docker instance as a way to run a command that will now give us access to the Postgres server, okay, using the Postgres client, okay, P, PG, PGQL, I think it is, PSQL, exactly. This is the client uh, completely. PSQL, that's the name of the client, all right, it's a terminal based front end. And Then I then I also look at how we can starting to explore the database, the most common command to explore that database, list existing database, list all the table relationship and constraint. Okay, uh, and then look at how you can create tables, how you can populate that, as well as how you can now alter commands. The idea here is that take a look at how you can model data, how you can populate the data, all right? Make yourself familiar with this, understanding that especially when you are capable to doing several transactions, or in this case with alter, you can create several operations or several transactions. And the great thing of this is that this only will work if all of those operations uh, are done, right? If that is a success. If not, then uh, none of those changes will apply. So you don't have to roll back. Okay, so you don't have your database in this inconsistent state. This also guarantee is this atomic, the principle of in which database management system follows, which is the atomic. Okay, so the atomicity of a particular statement that must have consistency in the database. It must be integral. So it must have integrity, and also it must be durable. So with this property, you can guarantee that anytime you access to the data, do it right or write, do a read or write, okay, you actually have your data in the proper state, not in a wonky state. Okay. Then we look at the SQL command. How interesting and how powerful is this, especially as you're starting to look now at the, well, how you can query your data, how you using select, and how you can also, uh, how first you can is populate your data using insert, how you can do massive insert, okay, and also do things like observe, okay, and how you can also work is, for example, with constraint when you are going to populate your data, uh, and also, and as we move on, the update command, so how you can update particularly properties, okay, using set, also how you can delete data, and then finally is how you can now, once you model the data, which means create a table, and then you, yeah, you create it. So once you create a table, okay, so once you create a table and insert it or you populate your data, you're starting to play with uh, upserts and deletions, and now it is time to look at what is the shape of this data, how this data looks like, how this Google spreadsheet looks like, all right, using select. So with select, you can now starting to use as a way to, well, get me all of the data from a particular table. That's great. A word of caution is like only pull the data that you really need to, because especially if you're working for a big company, imagine that you're working for Meta or for Google, it's like that, my friend, will now crash your server. Okay, so you actually don't want that. So the whole point of this is to, anytime you're going to explore the data in a database, be thoughtful about it. Okay, so avoid the use of asterisk unless you really need to. All right. And then we also look at how can we now, for example, do things like pagination. Okay, so because you have a lot of these records, all of these rows, so how you can do now pagination here using the offset. Okay, and the offset, it tells you is that what is the distance in a collection or in an object, what is the distance from the first element to that element, right? Or to the distance between the first element and that particular element. This is the offset, okay? In the context of computer science. So that's how you can now actually is implementing is your pagination. There's a word of caution here with offset because that might work for that that won't work well for tables that don't have an index. All right. And the idea of looking at this is as a way to see that you can work with them as long as they have an index. But when it comes to large scale uh, tables, or when you want to scale in your tables, there's an alternative to do that. Then we look at how you can now is, for example, search or select based on uh, search or based on text pattern. For example, like or I like, right? Instead of using the equal, which is a strict equality. So like is for this fuzzy search, and I like is for this fuzzy search says in case insensitive, string case insensitive. And what is the subtle difference between the parent, the percentage, and the underscore? Okay, with the with the percentage is to match zero or more characters, whether it is before or after the particular word you're looking for, or the term you're looking for, and then the underscore. Okay, so which indicates is, hey, I want you to match at least one of character. This is using for one character. And as we move on here, from all of the theory, we also look at how can we actually, in fact, create our own query from Node using Node Postgres, okay? And a recommendation from Brian Holt is like, write your own query, period. And to me, that's, I also develop a particular workflow from that, which is anytime you're going to query your data, getting into the database, okay, whether it's especially SQL database, getting into the database, write the query, okay, as a way to get what you want inside of the terminal, inside of the client, in our case, PSQL, okay, see that that actually gave you the result that you want, and then translate that to no. So in our case, we're going to use this the Node Postgres to prevent something called SQL injection. The TLDR is that you shouldn't trust the user inputs because what happened is that the user can try to hijack your application by adding is a particularly interesting and non-fun, uh, yeah, interesting and non-fun, which is ECX the okay, and you say mom, exploit of a mom, for example, this is some comic here, SQL injection comic, all right, as a way to explain that way much more, all right. So the whole idea here is to, hey, Never accept this user input because in the middle they can actually drop any table. You're gonna lose the data forever. So because of that, we have something called SQL parameterization. Okay, and this is something that comes here with the library here as a way to identify what are so behind the scenes as a way to identify what are the parameters you want is to pass. You want to sanitize that, and especially before writing your query, you need to also find a way to establish a connection. And the two way you have the client and the pool. So the client is especially when you create one single connection for the database. And this is great, for example, when you want is to write your own script. Okay. But for so now imagine that we have to handle this all of these incoming requests, hundreds of incoming requests or thousands of incoming requests. And each time you have to open a connection, which is open the socket, do the handshake, set up the authentication, and also establish the SSH connections. So all of this is very expensive. So in terms of time, so the idea with Pool is to ask the client, hey, uh, Pool, query this. TLDR is like that. It's like, hey, Pool, query this. And then we also look at how can we now create our own query from the server using Node.js, specifically Express, this web server. How interesting it was as a way to create, well, what are, give me all the type of ingredients. That was not that hard. And also it's like, okay, now I want you to search or I want you to paginate. Okay, I want you to search by a particular term on a table, all right? And I want you to now take a look at two columns using concatenation. I want you to take a look at these two columns and find any term that match with what we're looking for. So in our case, we want is to anytime the user hit the input or anytime the user for some reason wants to search whether it's on in the case of the table ingredients wants to search for the title of the ingredient or the type, we actually can get that, can give them as it is. That to me was oh, sorry. That to me was very very interesting. Okay, and now it's time to paginate that. All right. So that pagination we were using again, we use the offset just for demo purpose, and anytime you want to skip, we use is the limit. Okay, and the limit was fixed. Okay, we show off is a fixed limit. It can be 5, it can be 10, it can be 20, but in our case we fix that, do that. So that's great. You know, that's awesome. That's the way of how we can starting to see how can we paginate from the scratch a database. Okay, as you can see, we're using is the limit as well as the offset. All right, and the particular query and how you can now by using SQL functions such as count and another function which is the window, something that we're gonna see later. But how by using is these particular functions, now it will give you is properties. It will you can add that properties to the return result. So that was very, very interesting, completely. For example, in this case, right? Hey, give me all of the properties, all of the column from this table, ingredients, okay, and also give me another property on each one of those rows, okay, which is over on each one of those rows, where you have is the number of the rows that you have, okay, as total count. That will be the name of the property. And I want you to now evaluate an expression, okay, a where clause. which is what we're gonna search here. We're gonna concatenate here the title type in an insensitive case with the term that we're receiving, and after that, even that we if we have or not that term, then we're going to now uh, paginate this. Okay, offset here of $1. The pagination is here, as well as the limit. And then we pass that as the parent. All of this was interesting, okay? All of it was interesting as a way to get yourself familiar and develop this particular sense when it comes to actually create your own queries, okay? And the workflow of that. Good. Now we look at something that is especially important in relational database, which is join and constraint. Understand uh, relationships and joins, and how what happens when two tables love each other. So because here the way you can explain this is useful when it comes to ingredients and uh, recipes. Okay, so you can imagine if you have a table with ingredients, there are a lot of recipe that has ingredients. So whether it is uh, xiaolongbao, okay, xiaolongbao, whether it's shu longbao, okay, no xiaolongbao. Xiaolongbao is Cantonese, and Shulongbao is Chinese. Okay, Shulongbao, uh, Wolof rice, shakshuka, kachapuri. Okay, so all of these recipes. So we look at how we can populate that data, as well as how here we are going to develop or understand the relationship here. So, for example, you can have this relationship one to one, or one to many, or many to many. So, in our case, the relationship with ingredients and the recipe is that from the recipe perspective, okay, you can have one or multiple ingredients in a recipe. Okay, so this is one to many. And for the this can be one to many, right? And when it comes to now look at the relationship between the ingredients, an ingredient can be on a one. An ingredient uh, mm, cannot be an ingredient can can be in one recipe, okay, or not, all right. But the relationship here is one to many. You can have multiple. You can have the same you can have the same ingredient twice. Use only one to multiple recipes. Okay, that's kind of the relationship here. And that's exactly what we did here, and how this is very very important, and the core of this, because understanding this relationship, it'll make you, or it will give you sense of where is the type of data that we are modeling here. We're not gonna get it right, this relationship, okay, uh but the simpler we make this relationship, the better off we'll be for ourselves. That's also why we have, for example, other partners that actually have a little bit more experience in that field that you can ask for, okay. But that's the whole idea behind this, right? Is that, oh, okay, we got this, okay, we got this. So how will be is the relationship here? It's important, yeah, to understand this relationship as a way to know how you can populate your data. Okay. Uh, mm-hmm. Yeah, and they say be one approach will be to say, I only have the at most five picture of a recipe. This is when you're talking about is the picture. Okay, I'll make column pick one through pick five column and limit myself to that. Totally valid approach. And if you can guarantee only five image at most, it might be the right approach. But what if we can guarantee that? We need some sort of flexibility. That is where we can use two tables. Okay. So the idea here is that, for example, this part of this relationship, especially now for these two tables that we're going to create, the recipe and the recipe photo. So one approach for this of this relationship is like, okay, now I have all of this recipe that can have or that must only have at most five pictures of any recipe, right? But what if we can guarantee that? Okay, what if we can guarantee when there is what if we can guarantee that condition, especially when there is no image here? Okay, so the the reason or the idea behind of this, it has a way to understand how this relationship will work, one to many, many to many, or one to one, all right? Which at the end of the day, when you after you create your tables, which is something that we did here, the recipe and the recipe photos, okay? Uh, and when you want to now join tables or do this inner join as a way to uh, the TLDR of this inner join is to if there is a matching, if there is a one-on-one matching here, that's the whole point of using this inner join, right? Because inner join allows you to reach into the tables to combine data, okay? Reach into the table and combine data from it, okay? So, as you can see here, we're slowly getting to ourselves into look at the relationship as well as the joint statements as a way to now have much more insight of our data, of our business logic, of what's going on there. And Brian Holt recommends is that, hey, you know what? 90% of the time you're going to use inner join, 4.5% you're going to use the left join or right join, because after all, the inner join allow you to is it's like saying uh, matching it's like saying there should be one-to-one matching in each table. Okay, that's what it is. That's what it is. This is the inner joy in simple word. There should be one-to-one matching in each table. But what happened when you want to include is the data from one table or to another. That's when you do is the right and left join. Okay, so to put it simple here, anytime you want to do a right join, so the right table is whatever is on the left, whatever is on the front table. Okay, anything that is on the front is the left table, and anything is on the on is the right table. So the inner join is okay. Uh, what is the one-on-one matching here? Okay, that's the idea of inner join. What is the one-on-one matching here? However, if you want to now include data, all the data from one table, let's say from the right table, you go with the on, okay? Or you specify is, well, right join. If you want to now know the data on the left side, okay, you go now onto the front table, right? This is as a way to make yourself familiar, especially when you have to write these particular queries, okay? So when a particular business logic asks you to know the one-on-one matching in these particular tables, okay, now you know how to do that. Again, you have to create that relationship for that. All right. You have to create now this ID that can link to this table. So with this, by creating is this link, okay, or this relationship here, and we are just uh, simple. What we're doing is just simple things. So once you create this link from these two tables, the recipe as well as the photos, okay, so you can have at most five. So a recipe can have at most 5 rows or none of them, okay. So when you want to guarantee this particular scenario, it is useful to create a table, okay. So when you have this kind of relationship and you want to know is if there is a one-to-one matching, okay, you do is an inner join. Okay, so anytime a business logic, so anytime a company tells you, hey, I would like to know is the one-to-one matching. I want to know is if this actually is, for example, on the case of students and courses, is that how many, okay, I want to know is the list of students that are in this class. All right. So here you want to know is this one to one. Okay. In this inner join, you're gonna see this. You're gonna see is this relationship here. You're gonna see is how many of these students are in a particular uh, class. All right. Again, that table class must have the student ID. All right. So you can now keep track of them. And because one of those tables usually will have more data than the other, you're gonna see a lot of data, a lot of copy of that. So for example, you're gonna see a lot of copy from the class. So then we have to flat that thin before sending that to the API, right? So we have to collapse those down into one thin. So we have to collapse those down into one thing before we send that out. The idea here, which is something that to me is very, very beautiful and interesting, and something that I actually apply a lot in my life, is the relationship. Is the relationship of the things that I know, for example, in my own problems, uh, for example, hitting the gym or eating healthy. So, what is the different things? What is the relationship between the thing that I have to do and the thing that I let it go? You know, and as you can see the relationship of that. It is very interesting. Also, for example, if you want to see the relationship between your family members, uh, or the relationship, even though in movies, is like, okay, what is the relationship that have all of these different actors, okay, and actresses? That's something that anytime we go out to the cinema or we look at Netflix, we experience that, and we do that by default, even though when we are child, okay, even though when we are when we are young, we actually do that constantly. This is our nature of looking at the relationship. If you have 4 years old, you are constantly bombarded everything that move or not with why. You look at ant and you say, why do you move? You look at the sun, it's like, why you're there? You look at everything and you ask why, right? As a way to understand and to look at all of this relationship pretty much here in the table. Uh, and the way how now you create this relationship, okay, is by Right now, remember, we're having this silly exercise. Right now is by looking at if this table has a relationship and what is the type of relationship. Okay, whether it's this recipe has one or many, it can have non-image or it can have one up to five at most. Okay, so at most five image. All right, so how you can represent that relationship here. Okay, so you that's because of that you create a different tables. As you can see here, let's go. Hold on for a second. Okay, bear with me. Bear with me. For example, if you want to create now Facebook or any social media or database, aka servers that need to store is the relationship of data. So, for example, when you go to Wikipedia to click about SQL, and that link leads you to Postgres, and that link leads you to Frontend Master, and that link leads you to myself, and that link leads you to Microsoft, Reddit, blah blah blah, another company. It's like as you can see that, okay, how now you can create this kind of computer, aka server, that allows you to map this relationship blazing fast. That's what we have, for example, another type of database. So graph database. For example, Neo4j is that. I just wanted to bring this up because, as you can see, the relationship of the relational algebra or the relational database, the more this growth, the greater the headache. So you want to keep things as simple as much as possible. All right, and that's one of the things that I get from a lot of people, especially those who say, "Hey, you know what? I prefer to have one table per database." My man. Okay, that's good. That's good. You actually improving a lot of the read and write times. Uh, but yeah, yeah, that's that's an alternative here. You can also alter. Yeah, you can also alter. For example, let's say you have a user table here, and then down the line you want to add more data to that. For example, where they live, the geography, their nationality, what is currently right now, where is he gonna move, you know. And as you fill that data, there will be a lot of those rows without any data. Okay, so at the end of the day, it's like unless the user actually update the data, great. If it's not, the data will be blank. Uh, so this is also something that you can do here. All right. So you can add a lot of column here to represent is one record. There is another challenge here, especially for white column, which it says I have all of this record. I have all of this row. But the point here is that some of these records are different in shape. Okay, and I want to and I want to store them, okay, in this one table, right? That's the power of this. All right, the TLDR of all of this is, sorry, Whew. The TLDR of all of this is to say, hey, yeah, the TLDR of all of this is to say, hey, let's try to make our life simple. Yeah, we're not, this is not a good use of memory. I want to squeeze the yeah, I want to squeeze all of the or the most of our database by doing this. Is like, let's make it simple. All right. This is a programming concept. Keep it simple, my friend. Okay? Keep it simple. Kiss. And it's not the name of the band. Okay? It's not definitely the name of a band. It's and also it's a computer principle, right? Okay? Kiss. Okay? Keep it simple. Stupid. It is a design principle which states that designs and our systems should be as simple as possible. Whenever possible, complexity should be avoided in any system. And that's something that Brian Holt mentions that abstraction is the enemy of the good maintainable code. When he say that to me, it's like, oh, that's personal. And I'm gonna follow that. That's personal. And it is funny because this was Pri- okay, it's a design principle first noted in the U.S. Navy. Here we are. In the 60s, 1960. First seen partly in the American English. By at least 1938, the CRISP principles state that most systems work best if they are kept simple rather than made complicated. Therefore, simplicity should be a key goal in design, and unnecessary complexity should be avoided. The phrase has been associated with aircraft engineer Kelly Johnson. The term Kiss principle was popular used by 17 variations of the phrase, usually as some euphemism for more churlish stupid, included keep it super simple. Exact, usually as some euphemism for more churlish. Churlish. Oh my god, I love this. Churlish. Churlish. Rude. Rude, unfriendly, unpleasant. For more churlish. Oh my god. Include keep it super simple. Keep it simple, silly. Keep it short and simple. Keep it short and sweet. No, keep it short and simple. Yeah, but kiss. Keep it short and simple. Keep it simple and straightforward. Keep it small and simple. Keep it simple, soldier. Keep it simple, soldier. Keep it simple, sailor. Keep it simple, sweeties. Keep it simple, sweeties. Keep it stupidly simple. Keep it sweet and simple. Manténlo simple, amor. Manténlo simple, cariño. Manténlo simple, soldado. Manténlo simple, marino. Manténlo simple y sucinto. Oh my god. I will lead engineer at the Lockheed. Say no more. Say no more. Say no more. Say no more. Lockheed U2 and the SR-71. I get it. I get it. While popular use has transcribed it for decades as keep it simple, stupid, Johnson transcribed simple, keep it simple, stupid, no comma, and this reading is still used by many authors. But again, all of this comes from, mm-hmm, exactly, keep it simple. Henry David Thoreau, simplify, 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 for emphasis. So, yeah, simplicity, man, simplicity. So yeah, okay, that's the reason why, for example, while looking and exploring is now the relationship here, and as you can see, how the bigger the relationship you will have, the more it'll, the more cost it'll be, okay, or the most cognitive load it'll be. So again, this is something. Hmm. Hmm. That'll be something interesting to know. It's more like how many relationship a table should have. Okay, how many relationship a table should have? I will say up to five, no more than that. Is more than that is like no, no. Create a new table for that. Create a new table for that. hmm And even five is a lot, bro. Especially if that table is starting to grow in columns. I will say three at most. Four. Three is way too much. Three at most. Three at most. So makes sense. Makes sense. So now that we know the subtle difference between this relationship, so we understand the relationship as well as uh, so the relationship that can have across tables, as well as how you can now, for example, reach into tables and combine their data, okay, which is something that we put in here. Reach into tables, okay, and so reach into two different tables and get combined data from both of them, okay, and especially for example, when you want now to have, if there is one-on-one matching from one table to another, you use inner join. But if you want to include also the data from another table, whether it's on the right or the left, you do that, okay? Uh, and the way you write your query is like, well, let's go me select is the name of those tables or the name of those alias tables, followed by their properties that I want to get, okay? And then from the left table, okay, as part of the alias, I'm gonna perform an inner join. I'm gonna perform an inner join on. Yeah, I'm gonna perform an inner join on the recipe tables. Okay, which means is there is one to one, or there's a one-on-one matching here. All right, if it is, great, because usually those tables have different rows. Sometimes you will have, sometimes you will look at the table that has the list data copy with multiple copies. So that's why you want to flat or collapse down that data before sending to the API. All right. And well, this is just a brief explanation of this left right. When you do is this left right. Hey, I want you to do this inner join and also include the data is on the left table. All right. So, for example, if there is no relationship on the, yeah, if there is no matching on the left table, in the right, you will see then is an empty space in there, which is exactly what we look at this. All right, we were querying this recipe. In this recipe, we have is less data than the photo. All right, and from that, uh, we see that there actually is not any image in here. So that's interesting. That's also powerful. Okay. So in fact, uh, in fact, is this. There is also a word of this relationship, which is a word of relationship. hmm A word of relationship. The more relationship a table have, the more problematic it will be the more problematic it'll or the more problematic and slower the query, yeah, the more relationship a table have, the more problematic and slower the query will become. Okay, that's a word on relationship. So now that we know about this left right join in simple words, and I want to now is add this. Right, most of the time we're gonna do is this. 95% we're gonna do is inner joins. 4.5% is gonna do is this left join, left join or right join. You also want is to now say, hey, what if we? I don't want to include, or I want to exclude all of the data. Yeah, what if I want to? Uh, what if I don't want to include? Is there any one-to-one? This follow this Venn diagram. Okay. What if you? What if I don't want to include any of the one-to-one matching? I don't want to include them. What if I don't want to include them? All right. So for that, you do is a left join. Okay. You see, hey, let's going to select this right table and the left join from the table B, where the key in each one of them, where the key of B or the table on the right does not or is null in there. Hey, if there is a null key here, or if the key is null, all right, you're not going to include that. You're gonna get is all of this data here. So, and then you have, for example, is this full outer join, okay, as a way to say it's like, hey, I want you to know those users that are not, yeah, for example, here I want to include is I want to know those users that are blocked. Okay, so give me those users that I block them. A full outer join here. So okay, and then we look at natural join and cross join. So a natural join is because so natural join and cross join. Use this diagram to know what to do. A word on relationship, and then we're gonna look is at the natural join, and cross. Yeah, natural join and cross join. Exactly. Natural join and cross join. Okay. Natural join. Okay, and the other is a cross join. Postgres is Postgres is smart enough to join tables. All right. Exactly. Postgres is smart enough to figure it out what to join when you set, for example, okay, when you set, for example, recipe ID, or in other words, the name of the table followed by the name ID. So table name and ID. The problem with this approach, the problem with this approach, if that if someone for some reason change, so the problem with this approach, if for some reason someone someone change the exactly the problem with this approach is that if someone for some reason change uh, the name, all right, or add a name similar to that, uh, you it'll be it is uh, it is quite abstract. It is it is ambiguous. It is ambiguous. Ambiguous the result. It is ambiguous the result. So the idea of looking at this is that you recognize that that exists, but you shouldn't use it. Okay, it's because it is ambiguous. It is ambiguous. It is ambiguous because you're relying on this inner mechanism. And what if you, for example, someone that is new to that doesn't know more about this? It will cause a trouble. It will cause problem to that. So natural joins is something that it is important to know, but you shouldn't use it. Similar to cross join, when you have a cross join is more like a interesting interesting topic. Okay, it is not usually the most interesting top. It's not usually the most interest. It's not useful of joins since it perform uh, yeah since it performs computation, since it perform all possible, so since perform permutations. I think permutation is you're gonna get is this permutation. If I grade, you're gonna get this permutation, which means that you're gonna get all the possible combinations, and you definitely don't want to do that, man. You definitely don't want to do that, man. Oh yeah, it is for sure.
So, um, let's look a second at recipes for a second.
Buenos días, o bueno, quizás para usted buenas tardes, no sé qué hora se levanta. Habla Flor Vario, no sé si usted me recuerda, amiga y alumna de Diego. El jueves es mi cumpleaños y te estoy haciendo una invitación formal para que vengas. Diego te pasará las coordenadas.
Activo, marico.
From recipes, photos, natural joy, recipes.
La bicha está esperando, ¿me entiendes?
So,
You are playing
this
with
is
the
where
opportunities.
when you say
You are playing, you are
natural joy, it's like
gambling into Miss Life.
multiple columns of
Good
all the
luck.
same thing
I don't gambling with you,
tables
guys.
join on back.
Ah, perfecto,
So because I
agendado.
have recipe ID in both tables, it's smart to say like, okay, I see a recipe ID here, and a recipe ID here. I can
Por
join
eso,
both
I
sets.
don't deal with this kind of woman. I don't deal with this kind of woman. I can charge, I can be, She is, she is playing with the opportunity. Time to flex, bro. Time to flex. Yeah, it is.
Nothing else is called the same, so it ends up working okay. But like if I had title in both of them, it would try and do join on both of those. So this is why I don't use natural join hardly ever because it's pretty ambiguous.
Mm-hmm.
Nothing else is called the same, so it ends up working okay. But like if I had title in both of them, it would try and do
Mm-hmm.
join on both of those.
Exactly. But it's in both properties. Exactly. Uh-huh. Postgres is smart enough to figuring out what join you said, you said. If, for example, you have the same name property, exactly. For example, you have the same name property on each table, it will perform the join. The problem with this approach is that if someone for some reason change, exactly, the problem with this approach is that someone for some reason change the query, all right, it is ambiguous.
So this is why I don't use natural join hardly ever because it's pretty ambiguous. And imagine later that this works now, that my coworker later goes and adds a title to the photos. Maybe they have like captions or something, or body, right? They have captions. All of a sudden, it's going to try and match up bodies, and that doesn't make any sense. So
Exactly. If exactly with this approach, if that with this approach, the problem with this approach, if that is someone, yeah, the problem with this approach is that if someone for some reason change or add a property that a property needed to a table needed to a table, okay, change or adds a properly needed to a table, okay, natural join will join. Okay, will join. Oh my god. And we're back. Oh my god. uh, yep. Oh my god, bro. I was very interesting. Uh, what happened to me in the bathroom? But here we are. Yeah. All right, here we are. Here we go. Can you hear me? I think it is. Okay, that's perfect. Awesome. All right. Okay. So, exactly. That's the problem with natural joins. Is that say, okay, I'm gonna take a look at this column, and if they have the same name, I'm going to join. No, that's problematic because let's say someone, let's say a coworker, uh, with this approach that is, yeah, let's say with this approach, uh, if a coworker, okay, for some reason change or add a property to a table with the same name, okay, which is something that is possible. As you know, your database will evolve as business. So natural join will join the query. So natural join will join them. Will join them. And this is ambiguous. And this, okay, and this is ambiguous. So they do it. So the idea of looking at this is that you recognize that it exists, but you shouldn't use it. All right.
I wanted to show you that that exists, that people sometimes use it. It's really nice for just doing queries like this where I know they're called the same thing, but I don't suggest using it. And
Exactly. Brian Holt doesn't exactly doesn't doesn't suggest to use it. And because this man has worked for several companies, like, oh my god, all right, there you
let's
go.
talk about cross join because it's silly and it makes me happy.
Okay, cross join is more like an interesting math mathematical. Yeah, it's more like an interesting mathematical topic. It is silly. It is silly.
Let's say we had a set of three things: dog, cat, chicken, and we had a set of a second thing, colors, red, yellow, blue, or something like that. And you wanted to make red cat, red dog, red bird, blue cat, blue bird, blue, and like you wanted to make every permutation of all those things.
Mm-hmm. It is silly. It is not useful. It's not usually the most useful of joints. It performs permutation. Perform every single permutation of column and put them together. So it is important to understand that this is again where the value of this database come from is the ability to look at the relationship, the ability to create relationship, as well as the ability to join data as a way to make sense of that, as a way to make better decision making. That's the whole point of this. So is organize your data, look at the relationship, uh, yeah, organize your data, look at the relationship, and query them for better decision making, or join them. Okay, join them for better decision making.
Put together. That is called a cross join, and SQL can do that for you. So if I say select all,
So if you can do this permutation here, all right. So for example, you have 7 columns per 16, right? All right, we'll say that this is 6 element that you have exactly per 13. It's exactly what it's doing is that it's making each one of those possible combinations on all of this. So you have 6 elements in one table and 13 elements. It'll say, hey, this first element, I'm gonna create a table for all of these 13 elements. And then I go to the next row and I'm gonna do the same thing until I reach the last element on this column. So as you can see here, you're gonna get all of these possible permutations here
r dot title, r dot body, rp dot url. From
from
recipes,
recipes. And you're gonna do is now a cross join.
photos,
You're gonna do this just for fun. Okay, you're gonna do this just for fun here that we are inside here. So what you can do is select um, ref dot body. or the title from the recipe, recipe dot body, and the recipe photos URL. Okay, right now you're not able to see what I'm doing, but you will. Okay, and that is, yeah, and that is, uh-huh, what is this? No, yeah, okay, no problem. Not to hold joins here. That's right. Okay, good. And we're gonna do this. No, the hell is? Will you? Okay, what about now? Will you tell me is where are you looking for? Oh, I get the bloody browser. All right. Uh huh. Okay. All right. It makes sense. Cool. So now what I'm gonna do here is to uh, zoom this a little bit. No, I can zoom that. Impossible. Really? All right. Anyway, right now, Jesus, I can zoom that. Hmm. Anyway, zoom, zoom in terminal, VS Code. All right. View appearance zoom command. View appearance control equal. Well, that's exactly what I'm doing. It's like control, because I'm in Spanish. Okay, yeah, you are. Okay, awesome. Okay, thanks. So as you can see here now, more clearly, is I'm going to perform is a natural join. Okay, I mean a cross join, which is, hey, I want you to select is this particular property from this table, from the table on the left, and on the which is title and body, and for the table of the right, which is the URL. Okay. So the table from the left, it'll be the recipe, which is recipes. I want to give an alias of and here you're gonna say is cross join. All right. Uh, from so uh, uh, a cross join of, or in this case, all the permutation possible from one table column, which is, hey, you got this column. Hey, do you want a table of animals and a table of colors? Okay, you have chicken, cat, dog, and the other you have blue, white, and red. Okay, and then you say, hey, I got is the chicken with blue, white, and red. Then I got is the cat with blue, white, red, and you get it, right? So here, this is exactly what it's doing. This cross join. It's like, uh, all right, the table of the right, which is the recipe photos. They're going to rename that as RP. Okay, and that'll be all. That'll be all. That's right. That's right. As you can see, is that it's doing all of these permutations, and this is a lot. This is a lot. As you can see, it's 78 rows. This is a lot. You have to be careful when you use this. There are some scenarios that you might want to use that. Okay. And the other, okay, is the natural join. So because here we are in a relationship, I want to list, no, this is the database. I want now in fact is list the tables of this and the relationship here. And I want to take a look is at the recipe in this case, okay, as well as the recipe photos, okay. So a natural join. So here we got a URL, photo ID, the kind of thing, and the recipe ID and the recipe ID. So a natural join, let's say you say, hey, select, which is here. So a natural
All of a
join.
sudden it's been trying.
So for example, in a natural join, you say, hey, select all the property from all the columns from, like, but to be very precise, you have to describe this, okay, because the context is important. Select all of the columns from recipes, recipes, and do a natural join, okay, which is gonna take a look at what are those columns that have the same name and then join it together. Uh, Natural join from the recipe photos, and as you can see is this, right? uh, so if you can imagine that if you have, for example, a body property here, which in our case we don't have any title, but as you can see, the recipe ID is something that is combining, is merging from these tables. So you can do, for example, is a join, recipe from recipe, and do a full join. Full join, I think it's full join. Is it is when you're gonna get all of the table from this. Okay, when you're gonna get all of the table from this. It's a full order join table. Okay, it's a full order join table. It's a full outer join table. Yeah, it's a full all join table uh, on the recipes dot id dot recipe dot recipe id from one table, the recipe id from the table in recipe photos, and the recipe id from the public recipes. Right, the recipe id from this, and the recipes photos dot recipe id. And as you can see, it will now let me do this. In fact is doing is this. So you can see here, this full order join is now combining all the columns from one table to all the columns from the second table. That's what it's doing. So it reached to the table and combine all the data together. As you can see here, that's right. So this natural join, it will take a look at this recipe ID, or it will take a look at this tile, this column name that have the same name, and then join them. This, you might think that this is something interesting, but for example, if different tables have same properties, this can be problematic because it will give you an ambiguous result. So uh, I honestly recommend you to stay away from this. Completely. It's like, oh my god. It's like, oh my god. And especially when you're doing is this kind of thing, for example, natural join, stay away from this. It is interesting that it exists, natural join, you know, it's interesting that this exists, all right? But stay away from this. As you can see, what it's doing is that, hey, this particular column in these two tables actually have the same name. Let me merge it. Again, inner join is 90% of the thing that you're gonna do. Is you're gonna use inner join as a way to have is this one-on-one matching in one table and the another. Okay, 4.5% is the left join or a right join as a way to include the other set. Uh, and quite frankly, it's very weird. Okay, to say, hey, I want to now uh, exclude the result from one table and give me that, right? Those tables that are not in the other table, exactly like this. And the other is the full outer join, which is merging all of them, right? Merging all of this table with all of the properties. Okay. All right. Okay. 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 All right.
Match up bodies, and that doesn't make any sense. So I wanted to show you that that exists, that people sometimes use it. It's really nice for just doing queries like this where I know they're called the same thing, but I don't suggest using it.
Mm-hmm.
And let's talk about cross join because it's red, yellow, blue. I'm going to make every from recipes, photos, RP, permutation, all these that exist. It's a lot of rows. I'm so happy Brian taught me that. Other than that, it's just a curiosity that that does exist. But just be aware that like it quickly blooms out of control. If you cross join a table of 10,000 to another table of 10,000, you're going to get a lot of rows.
They quickly bloom. Oh, they quickly bloom of that.
Let's talk about foreign keys.
Okay.
So we have our recipes table.
Mm-hmm.
What happens if we delete from it?
Recipe tables. Okay.
So this is the Kachapuri. If we delete that, we still
Well, we won't have that reference.
have photos in the table.
Mm-hmm.
It's a problem, right? We don't want orphan photos. So let's just run that. Okay. And now we'll select book. We still have photos here, right? That's a problem. We don't want to have photos just hanging out in our database if they don't correspond to a recipe.
Okay, my friend. I'm slowly starting to see. Okay. I'm slowly starting to see. This is like, okay. Okay. So it's gonna delete this. Exactly. What if we want to delete this? No, no, keep moving, keep moving, keep moving.
Wouldn't it be good if we could like constrain that if we delete something from our recipes table, that necessarily those things have to go out of the photos table? Well, lo and behold, there's something called a foreign key that actually will do that for you. So I'm actually going to like reset my table right now because I want to make sure everything works the same way. So if you run this little query here, it'll just reset your table to everything being good data again.
So what you're doing here is a drop table if exists recipe, drop table if exists recipe photo, create table recipe again, all right, and then insert all of the values here. But as you can see, is look at this. So it dropped the table properly. It dropped the table properly, which is another transaction. It creates a table and then it insert the value here.
This is kind of an interesting one here, the if exists. So if it didn't exist, this wouldn't do anything. So this just adds like a bit of resiliency to say like, hey, if this exists, drop it. If not, do nothing. Okay, so we did that. Now we're gonna recreate our photos table a little bit differently this time. So create table, recipes, photos. Okay, we're gonna give it a photo ID of integer. We can also just give it ID, either is fine. Integer, primary,
This is the primary key.
key generated,
As
always
always
as
as
identity.
identity.
Okay, we're gonna have a URL which is a varchar 255, not null.
Is another property
We're gonna
here.
use this recipe ID, but we're gonna make this one a little bit different. It's gonna be an int,
Mm-hmm.
but it's gonna say references,
Mm-hmm.
recipes, the recipes table, and specifically the recipe table.
Mm-hmm. Mm-hmm.
Then you have to tell it what to do if a delete happens. So you could do on delete. There's like do nothing, I think. There's set null. Oh, so it's not do nothing. It's no action, which basically means, hey, if someone's trying to delete out of this table and has not already cleaned up the other table, just throw an error. Make them go clean the other thing first before you come back to me. Now I'm lazy because if someone deletes something from the recipes table, I just want to delete those photos, right? So I'm going to say on delete cascade. This is basically saying, hey, if someone actually deletes out of the recipes table, just delete everything that this references in the other table. So now if I run this delete that I ran up here, what would you expect to happen to its photos in the other table?
Which is in this case, they will delete on cascade. So they will be delete all of the references. But it
So
is
now,
interesting. You have not to create a reference. You have to tell that this is a reference
if I run this
for that.
delete that I ran up here,
By
what would you
creating
expect
as
to
a
happen to its
reference.
photos in the other table? There we go, right? They would delete. The delete would cascade to the recipes photos tables. If I put no action, then what it would do is this would error until I ran the delete on the other table first. And then if I did set null, what it would do is it would just set recipe ID to be null, right? So then I would have orphan photos, but they don't have any recipe IDs that they hook up with. So I just showed you here on delete. You can also put on an on update if there's some sort of like sync state between the two. Let's say I have like, I don't know, I'm making stuff up now, but like, let's say I have like English photos and French photos. And if I update a photo to be French instead of English, and you want that to update to cascade to the other one, you can handle that with the on update part of it. We're not going to do anything with that today. We're just going to roughly on delete. But that's what's cool about a foreign key is now I can have this like tight relationship between table A and table B. What's also cool about this, if I try and insert into, I don't know, insert into recipes, photos, values, I guess I could put here
And you're gonna check if that value actually exists,
title body,
which is the
other
shape.
values, um, some number that's not realistic, thing, other thing,
It's not created.
recipes, photos.
Recipes photos, exactly, that exists. It's a column title or relationship. Photo does not exist. Uh-huh.
Oh yeah. The recipes, photos,
It doesn't contain, exactly, it doesn't have any title. It's W.
and its URL.
It's URL.
Title body. Photo ID, recipe ID,
No, it's the
recipe ID,
URL. Hmm.
URL. Oh. Now, what it's going to tell me here, this violates the foreign key constraint, which basically said like, hey, you're trying to put something into the photos table that's trying
That's
to reference
trying to
something
reference something that doesn't
in the recipe table,
exist.
but that doesn't exist. I'm not going to let you insert this until you fix that.
Exactly.
So now I can't accidentally insert orphan photos as well. So that's what this foreign key constraint does, is it makes sure that these things stay in sync.
So, the idea of looking at this constraint, right? What is this? Yeah. So the idea now of looking at this constraint, which is very, very interesting and very, very important to know this relationships. Oh my God, yeah, it. Yeah, it. Exactly. So the idea of looking at this relationship, right, is to understand that uh, with a good example like this, because I really love this particular example, that if you sit here and how painful it is to actually uh, foreign foreign keys, is that how painful it is. The foreign key and managing reference. Exactly. Foreign keys and managing reference. So as you can see here, okay, this. So what happened? So what happened? Okay, and I really love this process because this is something that you started to make sense when you are creating your own narrative, or when you are now reading a narrative that actually is consistent, okay, with what you observe, especially a narrative, uh, the natural science. So when you are starting to understand this particularly natural narrative, right, and you start to develop is how is this particular story, you now understand the reason of why it actually came this. You know, you don't understand is where is the things are coming from. You know what I mean? You slowly to understand where all of these things are coming from. Completely, man. Where all of these things are coming from. Yeah, you slowly understand where all of these things are coming from, my friend. Oh my God. That's one of the reasons why it's so important is the narrative, man. Even for myself, it's like once I dedicate my time to actually get in to understand why am I working, why it is I have to work for the US, why is the US and not China, France, another country. It's like and understand their story. So once I understand this narrative, this history, all right, uh, things started to make much more sense, and now you can operate much more aligned to this. That's one of the reasons here, especially now, I understand genuinely for this foreign key and managing reference. Because what happened when you have, so what happened when you delete rows in another table, all right? What happened when you delete rows in another table? In our case, from the exactly in our case from the recipes photos. Okay, so what happened here, which is this, okay, uh, so what happened here, for example, this, I'm gonna regret this, delete one, okay, and now if I query that data, exactly. So what happened? This is if I delete in the recipe. Exactly. So what happened when you delete row when you delete a row from another table, in our case from recipes, okay, and now if you query that that data, and now if you query the photos or the recipes photos, okay, and now if you're querying the recipe photos, all right, you will hold that reference. It's stored there. It's is it is stored there. You see, when you are querying to that, it is stored there, bro. It's like no, no, no. So the thing here is that you are not. The thing here is that you now have data that have no reference, okay, which is one. You have data that have no reference, and now is in your, and now is in your, and now is, and now is, so now you have a data that have no reference and is stored, and now is stored in our data, and now is stored in our database. This is not efficient. This is not a efficient use of exactly. This is not an efficient use of space. So to solve this problem. And as you can see here, it's like, oh my God, if you don't define that relationship early, uh, you'll have some trouble. So it is better to have another table. And the thing is, and here's when things started to get quite messy. It's like it is better to create a new table, okay, that hold all of this data for that. So to solve this problem, and I get it why the people create white column, bro. Anyway, so to solve this problem, we need to recreate our table. Holy fucking hell! We need to recreate our uh, recipe table, okay, or recipes table. Jesus fucking Christ! So we need to recreate our recipes tables and provide a reference, okay, with a constraint to let Postgres what to do when something happened on delete, for example, on delete, on update, right? And that is now by looking is at the foreign, foreign keys in Postgres. But the idea of maintaining these foreign keys is just a way to efficiently remove reference when you don't need them or to update reference. Okay? Most of the time. Uh, referential integrity. But again, you are now reference cities. Exactly. Foreign key. Okay. Foreign key and managing reference is this. A more in depth is by doing this. For example, foreign key reference product number, as well as reference product and other table in here. You can also reference to three. But the idea here is to keep up is now is hold the reference of that. On delete restrict, on delete cascade, on delete exclusion constraint. This is a more in depth here. hmm But as a way to have consistency in your database and be efficient with your space, that's what we have memory here. So the things are aware of foreign keys, okay, as a way to have consistency and being efficient with your space in your database, okay, as a way to have consistency, sync, and being efficient with your space in your database, holding reference or foreign keys will help you to do that. Hmm, exactly. Consistency and being efficient. Exactly. Consistency and efficiency with your space in your database is the reason why holding reference foreign key will help you to do that. So online online bus, business. Okay. So online businesses. Yeah, online business. Yeah, I get it. Online business are looking for people who know how to talk to their data, how to model and talk. Yeah, man. This is where the value of this thing comes from. How to model and talk to data for consistency and efficiency with your space, with your space, with your space. Holding reference foreign key will help you to do that. So holding reference, so holding reference, exactly. So holding reference, so holding reference, combining data are just a cornerstone of this. Mm-hmm. Are just a cornerstone. So exact model and talk to data. Model and talk to data for consistency and efficiency with your space in your space and time. So model data. So create tables, holding reference, combining data are the cornerstone. Mm-hmm. Are the cornerstone. Yeah, are the cornerstone. Yeah, are the cornerstone for helping for helping business for helping online businesses. Completely, man. Completely, man. It's like, oh my god, you don't have idea, man. It's this, bro. Because now you slowly understand why you're doing this, and for who are you doing that. So in our case, because we already uh, delete our table, yeah, because we already delete our table, okay, exactly, we already delete our table, so we need to recreate, so we need to recreate our table, yeah, we need to recreate our table to keep it into a state that we want, or to keep into the state that we want, which is now doing is this drop table if it exists and then all of this thing. Which is in this case, hmm which is in this case is this. And all of the thing that you have to do here is like drop this table if it exists, drop this, o sea, you have now to remove those tables, all right, create their schema again, or create the shape of the data, and then populate them. Holy hell. And then populate them, all right, and then populate them. And now, mhm, and now, once you're able to do this, however, not like this, but it's time to create now this table with the reference. As you can see, you have now to delete those two tables. If you don't have Jesus, if you don't have that relationship here, that keep it simple, man. Keep it simple. Keep it simple. Oh my God, keep it simple, man. Oh my God, keep it simple. Because what you can do is to say, hey, let me create now a query from this. All right, as a way to not lose the reference, and then combine this foreign key as a way to now have a reference from multiple tables, and then create my own index. That makes that have a lot of sense. So here, what we're doing here is just creating this table. Here we're gonna say, hey, create table, all right, which is recipes, photos, where now the property will be is this. You'll have an ID. In this case, they call this photo ID. That'll be as an integer. No, I love it. Doesn't help me here. And there's some column constraint, like column or table constraint. Primary key generated always as identity. All right. So you now have this relationship or this sequence, all right, as a way to help the database to now, uh, anytime you want to, which is here what we're creating is an index, okay? Anytime you query data, do that fast, okay? Into your primary key generate always as identity, okay? A comma. The other property here, which is the URL, lowercase, URL, varchar of 250, that's right, is require. And another property which is the recipe underscore id, that it will be an integer, okay, uh, but it also will have this another, and I will take a look here, is on the table, especially on the SQL reference, primary key and foreign key, because it's creating is a reference here, okay. PSQL PostgreSQL does not support check constraint that reference stable data other than new or updated row. While a check constraint that violates this rule may appear to work in simple tests, it cannot guarantee that the database will not reach a state in which the constraint condition is false, the subsequent change of the other rows. But again, keep it simple, man. Keep it simple. Keep it very, very, very simple. Give the manual here. And I want to take a look is at the tables data definition, or in this case is on the reference. Okay, inheriting foreign system column constraint modifying tables. Table basics. Ah, but this is no. This is explaining about how you can create this. Okay. No, this is more like okay. I get it. But the idea here is to look at the tables, the reference, alter table. No, but table plain table. All right. It must be. Or you what? Select t. What the LPRT. Where is T? Is this for really table? I get it. It's by the command. It's like create table. Jesus. Mm-hmm. And then you got it here, right? Where column constraint is this, or where table constraint is this? That's interesting. Okay, where column constraint, which is in this particular case, okay, column name data type, okay, or column constraint here. You also can have some table constraint. I don't see any of that table constraint. Okay, there you got it. You can have this column constraint, all right, or table constraint, where the column constraint here, where it is, well, column constraint, it can be any of this, generate always as, unique, primary key, and reference. Okay, this is column constraint, all right, and this is table constraint. So here we're doing is that reference. There is no need to actually memorize this kind of thing, but it is interesting to know where it comes from. Here you're making is a column constraint with reference, okay, reference, a column constraint, okay, where here you're going to be able to say, hey, the column constraint reference, which, okay, what is the name of that? Oh, the way to do this is by having giving us the referential table as well as the column. All right, this will be recipe here, and the recipe ID, the property that must be in that table. And then you have is the thing that you can do. So on update, on delete, deferrable, not deferrable, that kind of thing. Okay, in our case, on delete, okay, and then you say referential action. What you want to do on delete? Referential action, no actions, restrain, cascade, set to null. Okay, so you want to now this. Referential action is a foreign key reference constraint. Most of the time we use is on delete, cascade, but you perhaps wants to now when you want to delete that, you set null to that row. Again, you in fact have that, okay, you will store data in there, and that might be your case or not. It's a recipe does not exist because it's recipes, exactly in plural, recipe ID, create table, that's right, awesome, lovely, all right. and and here is when we create such reference in the recipes table, On the recipes photos. hmm In the recipes photos. Okay. Table. In the recipes photos table, you're going to create. Oh my god. Uh, Drop table if exists. Okay. Drop table if exists. Recipe photos. I wanna take a look something. Before doing this, the recipes photos. How do you create that relationship? Generate always as identity, and then you have is the foreign key recipe ID reference to recipes recipe ID on delete. Oh, okay, that's exactly the constraint that I want to look at this. Okay, recipe photo, recipe ID, foreign key. All right, there's a way to have this reference, but this is exactly on that particular table you want to have a reference to that. Okay, on the recipe photos, which is this. Exactly. All right, that's that's great. That's interesting. And that's also powerful here. So the reference portion means that you're going to be a foreign key. This will be a foreign key, and you tell what is going on to match up. Okay. So this reference is say, hey, you're going to now reference to this. So key important things here. Reference. The portion mean is going to be a foreign key and tells you what's going on to match up to. In our case, recipes on the table, recipe ID is the name of the color. It'll match. Okay, the reference here is the column you want to match. You want to match up, or you want to match up to the recipes table. All right, to the recipe tables. That's right. You can also do on delete set null, which does exactly what it does. There is also on delete no action, which is will error out if you try to delete something from recipe. If there is a still photo left, this for developer to clean out photos before deleting recipes. That can be helpful. Okay. Hey, I want you to delete all of these photos before. Okay. So on delete no action, which will error out if you try to delete something from recipes. If there is still photos left. Interesting. Interesting here. There is on delete no action which will error on delete no action which will error if you try to delete something from the recipes if there is still photos left. Okay, this forces developers to clean up photos. Exactly. So this forces developer to clean up photos first before removing that. hmm And there is also an update if you need to handle some sync state between the two tables. For sync, it'll have that. It makes useful constraint to make sure delete and update behaviors are intentionally and makes the queries faster. If you're going to have if you're going to have two tables referring each other, use foreign key where possible. it may useful constraint to make sure your delete and update behaviors are intentional and it makes queries faster. hmm This is an optimization that you can do here, especially with this reference here. Especially with this reference, you're going to have two tables reference each other. Use foreign key where possible. It makes useful constraint to make sure delete on update behaviors are unintentionally and make it query faster. Okay, so what's next? So the TLDR of this foreign key is that if you want to maintain consistency, because it's this, if you want to maintain consistency, you know, if you want to maintain consistency and efficiency with your space and time, okay, foreign key will help you to do that by holding is the table. Yeah, because after all, you don't have. So if you remove, for example, which is in our case here, if we remove is a particular recipe, you will also remove all of the reference if you have that constraints. An update, and perhaps an on delete, you do this. An on update, you do this, right? Hmm. Okay. And then we talk about is
This is
many to many.
one to many relationships. Now we're going to do
Exactly. We have done is one to many relationship from the recipe photos or from the recipes, which is one recipe contains it can contain zero or many photos. Okay.
many to many. We already discussed what it is. It's a recipe contains many ingredients.
Okay. So this is the relationship here. So a recipe can contain many ingredients in this. hmm That's one of the relationship. A recipe can contain is many ingredients,
Belongs to many recipes. So
and ingredients may belong to many recipes.
how do we model those things together, right? There's not like a one table to one table relationship where if I have something here, it exists over here. I need another intermediary. So we're actually going to add a third table to model that. So let's go ahead and do that. We're going to create a table called recipe ingredients. It's going to have a recipe ID that is an integer that references recipes, recipe ID,
Your creating is
on
now a
delete,
reference to that.
no action. Why am I putting on delete no action here?
Because here you're creating is this table, right? This recipe ingredients. And as you can see here, you just wants to hold is a reference of this. Okay? What the reason why you're doing is this uh, is because you want to hold is only a reference from the recipe ID here. Is that yeah, you want to hold is a reference for this, which means that with recipe ingredients you want to have is how many ingredients a recipe contains. That's the reasoning about it.
If I have, I mean,
Another perspective is that if I have an ingredient,
ingredient and I delete like the connection between the recipe and the ingredient, I don't want to delete both recipes and the ingredient, which then have cascading deletes, which then go back and delete things. You'd eventually kind of like wipe out your entire database accidentally. So if you're trying to delete a recipe, basically what you're saying is like you have to go clear out the recipes ingredients table first, all of the connections first before I let you delete the recipe. So you would, which then have cascading deletes, which then go back and delete things. You would eventually kind of like wipe out your entire database accidentally. So if you're trying to delete a recipe, basically what you're saying is like you have to go clear out the recipes ingredients table first, all of the connections first, before I let you delete the recipe. Ingredient, which then have cascading deletes, which then go back and delete things. You would eventually kind of like wipe out your entire database accidentally. So if you're trying to delete a recipe, basically
Exactly. If you try to delete a recipe, is that I don't want to. I just want to hold the reference of that.
what you're saying is like you have to go clear out the recipes ingredients table first, all of the connections first, before I let you delete the recipe.
You're telling us this. You're basically saying is that you have to clean out all of the recipe.
So if you're trying to delete a recipe, basically what you're saying is like you have to go clear out the recipes ingredients table first, all of the connections first, before I let you delete the recipe. So you would start by deleting things out of this table first before you go delete recipes or ingredients. Okay, I'm going to have an ingredient ID, int references ingredients on its ID, on delete no action. Okay, you need some sort of primary key because every table has a primary key, but I could just insert like a connection ID or something like that, or just give it like a normal ID. However, we're never going to query this table for a specific connection. We actually don't really care about the individual connection objects. We care about all about is just joining the two tables using this intermediary table. So instead of having some third ID, what I'm going to do is I'm going to have a combined or a compound
Mm-hmm.
index that combines them together and asserts their uniqueness. So I'm going to say constraint recipe ingredients. I'm giving it a name. That's what this is. PK for primary key. Primary key of recipe ID.
So you are combining is this reference. Mm. Oh, you miss is a comma. No, exactly. You miss a comma.
So what this line is asserting is the primary key of this table is the combination of recipe ID and ingredient ID.
Mm-hmm.
That should be
Is this a
guaranteed in
guarantee?
this table.
Exactly.
Because it doesn't make sense that that flour would be the same ingredients twice in one recipe. It's just the one recipe, right? So if I try and insert like egg twice into the cookie recipe, it's going to say you already have this in here. There's no need to connect it again. You don't need multiple one connections. You have one connection. Make sense? Okay. So now if I look at my recipe ingredients, I have this recipe ID and ingredients ID, and then my foreign key
And the
constraint is that
indexes.
recipe ID exists in recipe, the ingredient exists in the ingredient one, and the combination of the two is unique. This is how you model many-to-many relationships using SQL. All right, let's go ahead and go insert some things into that
Mm-hmm.
database. I'm just going to copy and paste this because
This
it's
is how
not
you
that
model
interesting.
many to many relationships. Because we so far we have looked at how to model. Oh my god. Okay, many to many.
Okay, so now
Many
if I
to
select
many
star for
recipes ingredients into this table. How you mapping and how you
I have
indexes.
some rows in here. These are guaranteed
Exactly.
to
How
be
you
in ingredient, these are
mapping
guaranteed to be in recipe.
is this.
However, the connections themselves are wholly uninteresting, right? I would never like want to return this to a user. I want to see what's in the recipe and I want to see what the ingredient is. But notice I have 1, 1, 1, so these are all the same, and I have 13 and 13 here. So ingredients can exist in multiple recipes. Recipes can have multiple of the same ingredient. It's just a combination of the two that's unique.
Mm-hmm.
Okay. Now let's say instead of having recipe ID 1 here, I want to have the actual recipe. Instead of having the ingredient ID here, I want to have the ingredient. How do I do that?
By querying the
Join
data.
between them, just good job. But the
By
second
querying
thing
the
is
data.
we have to do multiple joins. We have to join a couple of times. So we're going to select i.title, and you can actually give them names if it's a little bit easier for you. So that's what this as keyword does. Select the ingredient title as ingredient title, if that's clearer to you. This is just going to be the name of like in the table that it returns to you, right? I.image as ingredient image. I.type
As a way to
as
create this many to many relationship in this table
type.
using the combine, using this combined primary key from this table.
So
This is
first
to
thing
see
we're just going to do the
relationship.
ingredient part first, and then we'll go back and we'll do the recipe one. So from recipe ingredients ri inner join
Inner join as a way to now have this to combine, as a way to now reach into two's table and get me those that match, as a way to reach in these two tables, uh, as a way to reach into these two different tables and combine their data to match one to one. Okay, which is the recipe ID and the ingredient ID. So if this reference that I hold in here from this table as a way to know what are the ingredients for this recipe or the uh, recipe ingredients, okay,
ingredients on
is that from the right table from recipe ingredients
I
and the inner ingredients where the this is actually something it doesn't matter, but on the recipe ingredients.id and the recipe on the ingredients ID, I think it is on the recipe ID
ri
ID.
ingredient ID, where we'll just grab one of them.
Exactly. So you're going now to combine this, okay? You're now going to combine this and create a new query that actually gives you is the ingredient title, the ingredient image, and the ingredient type. Okay. Hmm. The ingredient title, the ingredient image, and the ingredient type of this. Okay, the title, the image, and the type from this ingredient, which is something that you might have in that particular table. Okay, so I want now to is join this. I want now to get, and I want to combine this column from, and I want to combine is, and I want to reach into these two different tables and combine their columns that the ID and the ingredient match. Okay, and here is where I want to do something else where uh that's interesting because it will give you all of this cross, all of this inner join, okay, all of this one to many, and remember exactly it's because it gives you is all of this one to many, and because one table might have uh, more data than the other, you will end up with copies. You will have with multiple copies in the table that have the in the in the table with less data, okay, or with the less size, or with the smaller size, you're gonna have all of this. So what you want to do is that, well, I want to flat that. I want to, yeah, I want to know a way to flat this or to collapse this.
ri dot recipe id equals 1.
Okay. So here, by telling now the recipe here to the smaller one or to the left or right table, in this case, the right table, you're telling, hey, the recipe ingredients, I want you to now get me all of the data that contains a recipe ID 1. What will be the output of this? It'll have a row, but it will have a row that contains title, title, image, and type. Okay, it will combine these two tables, the recipe and ingredients. Okay, the recipe and ingredients. It will combine that and give me is the one-to-one match that actually are in both of these tables. All right, and where the ID on the recipe ID is equal to 1. So where this ID is 1, recipe ingredient does not exist.
What did I mess up here? Recipes, ingredients. See, I mess this up all the time. Recipe ingredient.
Recipe ingredient.
There we go. So I went and grabbed all the ingredients for recipe 1.
So I went from the recipe ingredients and I get only the ones, all right? And I am now selecting which one of them are actually is 101 on the ingredients table. Hey, is this one actually is on the is this recipe uh, ID is now on the, yeah, is this recipe ID is now on the, is this recipe ID is 1, all right? If it is, now give me the relationship from that.
1, which I think is cookies. So, but in case you know, carrots, cauliflowers, and chicken going to be cookies. But these are nonsensical recipes, so don't worry too much about that. So this got us all the ingredients, but it doesn't tell us what the recipes are, right? So how do we get the recipes in here? We're going to have to do another inner join. So let's do that. We're going to do, oh, okay. Let's do this in code because this is going to be so much easier for you to visualize this.
Yeah.
So I'm going to do select title as ingredient title. We're going to do i.image as ingredient image. And then we're going to do i.type as ingredient type. But we're also going to grab from R, which is going to be recipe, we're going to grab r.title as recipe title. What else do we have in there? Recipes, the body. So we'll grab the body as well. So we'll grab r.body as recipe
So we're
body.
gonna do a,
And if you want, you can grab the IDs as well. r.id as RID and I.I. Except this is recipe ID.
exactly, recipe ID.
And then I.ID as ID. Okay, we're going to do a from. We're going to do
Okay. So what you can
recipe
do here is to now
ingredients are
define it is the relationship of one to many to many.
okay. You have to inner join. I'm gonna try and space these out a little bit so it's a little bit easier to read. Inner join ingredients I on
Okay, so from this table that you have the relationship here. Okay.
I dot ID equals RI dot ingredient ID. Okay. Inner join again.
Mm-hmm.
Recipes are on R dot recipe ID equals RI dot recipe ID. In theory, you could do a natural join
Interesting.
with the join. And then here, after that, you could put your where clause if you wanted to. You could say,
Oh my God, you're doing this from this recipe and you're comparing with these ingredients. And then you're doing this recipe and you're comparing it with the holy shit. It's like, man. Oh, for fuck's sake, man. Laser focus. Okay, if you have this from recipe ingredient here, you say,
RI, whatever, blah, blah, blah. We're not going to do that. We'll just have all of them.
God damn it, bro.
And let's see if that works.
Again, this is actually is to give you is this combination, this join from one table and the another. Okay, and those ID that match. Okay, and those ID that matches ingredients, and those ID that match is exactly those ID that match with my exactly. That's what you do is those ingredients that match. Okay, this will give you is one-on-one matching, one-on-one matching data here. So it will tell you is like, hey, I want to give me is this relationship, all right, of those ingredients or of those unique ingredients because it's gonna give you is this the ingredient. It's gonna give you that, all right, as well as the recipe here. But I give you
Say where RI, whatever, blah, blah, blah. We're not going to do that. We'll just grab all of them.
exactly for this case, we're gonna grab all of them.
And let's see if that works.
So this will create is a lot of copy, by the way, or not. Yeah, it will create some duplicate copies from that. Again, but here we're gonna get is this uniqueness on this ID. Ingredient title, ingredient name, ingredient image, ingredient type, recipe title, and recipe body. In a cookie, or you can have carrot, you can have cauliflower, you can have chicken. This is cookie, yeah. You can have bananas, or you can have chicken in your empanada. Yep, that's right. So here you're gonna get is this um, ID that are unique and that have this reference
There you go.
one to many, many to many
So the recipe here, cookies, cookies, cookies. This is coming from the recipe table. The ingredients type is coming from the ingredients
from the
table.
ingredient
And
tables.
we have all of these connections that exist because because of that recipe ID or the recipe ingredients table that exists there in the middle, right? If you remember, we inserted this is coming from the recipe table. The ingredients type is coming from the ingredients table, and we have all of these connections that exist because of that recipe ID or the recipe
ingredients table that exists in there.
Right. If you remember, we inserted where are we? Up here. We inserted 5 different rows of just numbers that correspond to both tables, and then we used the joins here to grab the information from both tables, so therefore we can see all of the ingredients in all of these recipes. So 5 insertions, we have 5 rows here.
Exactly.
But this is kind of how you use these like relational tables to join information to build each other up into these big things. And then using foreign key constraints, we can kind of guarantee that everything stays the same. And you can see here when you start joining a lot of tables, it's really useful to have these short table names. Frequently, people make them 1 to 2 letters. It's probably a little bit excessive. In a very short query like this, it's probably fine. But if you're writing like 100-line queries, which is not that uncommon, you probably want to have a little bit
100 lines of query, which is not
description. Like I might call this like ing and recipe or something like that. But typing out recipe ingredients 50 times sounds wholly inhuman to me, so it's kind of up to you. But yeah, this is how you model many-to-many relationships. So let's go talk about constraints. We already saw this constraint here, which is basically a constraint is exactly what it sounds like. You're saying this column has some sort of rule about it, as opposed to something like body, like the body of text, right, that exists on recipe. There's just no rules for that. You can put literally whatever you want there. Constraints is basically saying, like, in order for this to be inserted here, it has to satisfy this rule before I'm going to let you do that. So we've seen one. One was that there must be a unique combination between recipe ID and ingredient ID. That's a constraint. Unique, if you remember unique that we did earlier on the title of ingredients, unique is considered a constraint as well. Primary key, that's a constraint technically. Foreign keys, technically a constraint, right? Because you constrain that this has to exist in the other table. Let's do one for our types, right? Because we either have meat, fruit, vegetable, or other. So you can basically say this has to exist amongst these things or I won't let it in here. It's essentially an enumerated type.
It's a number.
I use that word kind of cautiously because there's actually a separate concept in Postgres called enumerated types you could also use here. There's a bunch of ways to do it. I'm just going to show you the way to do with this like check thing. So let's go ahead and type that into our table. We can say alter table ingredients.
What to create?
Add constraint. Type enums or type check or enums, whatever. It's just whatever you want to have it show up as. Doesn't matter. Check. And you're going to say type has to be in, has to be one of these. A meat, a fruit, a vegetable, an other, and that's it. So now we have a check constraint in here. So if I try and do something like this, I'm just going to copy that. insert into ingredients where title image type. So this right here, going into type is obviously not a type, right? It's not in our meat, fruit, vegetable, or other. It's going to fail because it's going to say this failed that obviously not a type is not in our meat, fruit, vegetable. So it's just allowing you to set some rules and boundaries around your data. And at this point, it kind of bears mentioning, this is like one of the primary points of using an SQL database, particularly Postgres or MySQL one of these, is that if you have highly structured data with schema that have a lot of rules around it, like this can be this and can't be that, and should be this and can't be less than this, SQL is really good at stuff like this. It's really good if you can give it specific rules of enforcing that those rules stay consistent. If you go into things like Redis and MongoDB and some of those other ones, they have some ability to do some of that, but it's not necessarily as built for. Whereas SQL is like it just thrives on constraints and rules and stuff like that. So, yeah, this is like the primary use case of when you want to use SQL.
Mm-hmm.
Yeah. Well, hold on. The answer is it's going to fail if we try to do this and we have like a spice in there or something like that. I imagine, and I've never tried this. There's something to say like on fail, do something like this. On conflict, set to be a default. But really, what you want to do is you just want to go update all this yourself before you do that. So I'm showing you all these like alter table kind of commands, just so you know that once you set a table, you don't have to like live and die with that. You have to drop it to recreate it. You can't alter them. It's really expensive on big tables. Like I remember when I worked at Reddit, we had to run like database migrations from one schema to another. It would take hours because the Reddit has huge, huge tables, as you might
Completely.
imagine. It has every comment and every user and every upvote ever existing in there. They're huge tables. So you really don't want to run alter table haphazardly. You need to like plan for it. It probably has like scheduled downtime and things like that. So if you're adding a constraint that didn't exist before, in that case, I probably wouldn't even add it. It's probably not worth it. But if I was going to do it, what I would do is that. So if you're adding a constraint that didn't exist before, in that case, I probably wouldn't even add it. It's probably not worth it. But if I was going to do it, what I would do is I would go update manually all the things that were in conflict, and then I would run it.
It's a lot of gene, bro.
So we did constraints, and now we're going to.
Okay. 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 So that'll be all for this video. Take care. Bye bye.